everyone. This is Niharika Kolongi. I'm the part of administration development from Haldari Technologies Private Limited. This evening we have dialogue 5 to begin with. Welcome you all the moderators and panelists and all. Haldari Technologies Private Limited founded by Sri Lakshman Kanikanti. Let's take this opportunity to introduce two moderators of the day. Dr. Kishore ATSO is an ex-Indian Air Force officer. He comes with enormous experience and telecommunications and aeronautical engineering, and he contributed to the development of Bureau of Indian Standard Documents for training of agriculture uses of UAV, and it is now maintained by Manak database by Government of India. And he also worked with both the panelists on various agriculture problems and their solutions, including smart UAV, IoT, and UGVs. Welcome you, and you will listen to Dr. Kishore sir and his team. So the floor is yours, Dr. Kishore sir and the panel. Thank you.
Thank you very much, Niharika, and welcome
Thank
you
you, sir.
all for this fifth edition of KhetiValah's Dialogue. And this evening, we are very glad to have two stalwarts who have really done extremely brilliant work that is likely to get awards for their path-breaking research in both UAVs and UGVs. Not much literature and work is evident in the unmanned ground vehicles. For UAV, most of the attendees may be already aware they are drones. Simple definition of a drone is dynamic, remotely operated navigation equipment. And India, along with the rest of the world, is going to witness a huge proliferation of them. The number of UAVs will exceed the number of electrical vehicles at one point of time. And we will see by 2030, India has aspirations to become the global headquarters for the UAV, at least in the point of view of software development and operations and beyond visual line of sight. In fact, just before this event, I'm part of the Bureau of Indian Standards deliberations on UAV traffic management, and agriculture is focus for the government of India. I, along with others, contributed to the standard as Niharika mentioned. So without much delay, I would touch base on the topic of the day. So UAVs and UGVs, what are they? So think of one sophisticated Volvo, and it's a specially designed Volvo, and it opens a canopy, and then you have lots of UAVs coming out and doing a lot of magic. So that's going to be the combination of the chemistry between UAVs and UGVs. And this is already happening. American Postal Service is using the vehicles carrying the drones and to certain point. And when the address comes, the drone will go just like a Harry Potter's owl. It will go and drop the letters there, and that's already happening. And also, drone deliveries are happening in America and Europe. And during the pandemic days, intercontinental drone transport also was tested. Now I would like to continue with the presentation. So there is going to be a lot of developments which you will see as students and researchers, that the drones behave just like intelligent birds, metallic birds, just like a bird sitting on a tree branch. The drones may rest for a while for their docking station, just like space station. We have Chandrayaan 3 on the sky. And so the drones will automatically think what is required during the resting period, reprogram itself and prepare for the next mission. And so between start to destination, it will take some kind of a sojourn in between journey, and it will recoup itself, recharge, and maybe it will do financial transactions to get maintenance and reprogram and solve some technical problems. That's how is the world going to be more and more Industry 5.0, 6.0, 7.0, and drones and UAVs are going to solve much of the challenges that we have in agriculture field. Let us see the details. KhetiValah brings you this dialogue. It's connecting the farmers to the for dreamers, cultivating a prosperous future for farmers' welfare. A product of Haldari Technologies Private Limited. It's based out of Gurgaon, Bangalore, Hyderabad, and expanding to many other cities. That is our website, khetivalah.com. We would like to briefly introduce who we are. KhetiValah is one of the kind of agricultural app, which is an Android app, and we will also have it in all other flavors that empowers the farmers with right guidance and financial assistance from visionary investors who are passionate about farming. We believe in the visual role of farmers and their contribution to the society. As a gesture of gratitude to farmers who work tirelessly to ensure food to the population, we know we are touching like beyond 9 billion by 2030, and there is going to be a food crisis. We launched KhetiValah, a farmer-friendly app that supports farmers' journey to progress. So we are in the solution to the problem. I'm going to admit some who are asking me while I'm speaking. So others also, when you get alert, please admit them. Okay. So what we do at KhetiValah is we are designed as a one-stop solution for the farmers seeking financial assistance, advisory services, updates, and market linkage. And we connect with what we call as Niveshaks, who are forward-looking and thinkers and who love farming and they want to support farmers. We also do knowledge sharing platform, and we do sales assistance and market linkage as well. How do we accomplish all these objectives? We are giving back to the farming community. Our central objective is our farming features and activities are streamlined as KhetiValah Anusandhan and Kheti Kalyan, KhetiValah Kheti Kalyan, and Mandal Kendra's KhetiValah magazine and YouTube channel. I will briefly touch base on them before we step into our topic of the day. So firstly, Anusandhan is we meet brilliant people, intelligent people, and those who are focused on connecting, who care about farming as much as we are enthusiastic about. As we are inspired, we also want to meet like-minded individuals. Those of you who are attending are also some of them who would like to connect. Connect farmers with investors, collaboration with agriculture stakeholders, explore new avenues in sustainable farming practices and crop improvement techniques and technology integration. So we have KhetiValah Kheti Kalyan concept, where we bring the farmers and Niveshaks together, conducting Kheti Kalyan event, and they handshake with each other, and they go to each other's places. The investor visits the field where crops can be cultivated. That is the bridge act we are doing, and that's how we achieve the much needed positivism in this agriculture industry. So we have started the concept of kind of discourse or dialogue. We call like a Man Ki Baat. It is agriculture related thinkers sharing of their views. They're intellectuals, they're experts. Like in this session, we have Dr. Dr. Sumita and Dr. Um, from Nashik, Madam Gayatri, and so we will hear from them both. So this dialogue is focusing on the agriculture based problems and their solutions and how to resolve them, and then some of the research ideas will be converted into practical industry work, or can be taken up as entrepreneurs and go into startups and incubation as a separate topic altogether. So what we do in dialogues is we bring some valuable insights on various agricultural aspects, and we conduct sessions on trending topics and challenges. We conduct talks by subject matter experts, inspiring accountability and innovation, and we bring specialists from agriculture companies and professionals and farmers also. Collaboration and gathering crucial feedback is our central motto. So we not only do this dialogue, we meet them in person, we conduct events, and we talk to them, take these ideas further. So there is a concept of Mandal Kendras already, and here we use this opportunity to enhance the smart farming through efficient machines. This is facilitated through Mandal Kendras, which are providing the machinery based on crop grown in a particular area, from crop drones to monitor the drones. And that's what today's topic is: UAVs and UGVs. Lot of case studies and use cases. Professional farming advice and inspiring accountability, guidance, convenient input sales for all the agriculture supplies, and financial and marketing guidance. Supply of high quality seeds and pesticides also to Indian farmers. So we have KhetiValah magazine, wherein our dialogues and other details are printed there, and we bring some inspiring stories about farmers, glimpses into innovative agricultural practices, updates on drone developments, pesticides, guidance on effective farming methods, entrepreneur endeavors that revolutionize farming sector, information on machine usage, technical specifications, and financial assist options that and subsidies for the community. So we have a YouTube channel. As I said, this particular talk is also going live on YouTube. So this is how we want the entire community to be benefited. It will be in a repository, digitally available, and we gain valuable insights from interviews from industry experts, discover some cutting edge technologies and practices that are revolutionizing the agriculture sector, and gather some technical information. So we also have something called electronic KhetiValah or e-KhetiValah that provides platform for farmers to sell their agricultural produce and bridge the gap between farmers and consumers, simplify the sales and ensure fair margin, and boost the profitability to farmers. Farmer is the key focus of our entire mission. And we also have Kheti Kosha. In English, it is called Land Bank of Agriculture. And we want to nurture the farms and cultivate prosperity through this mission. And we are talking to various stakeholders, landowners, to lease their land, wherein the landless and small marginal farmers can practice farming. This ensures a reliable stream of income to landowners as well as farmers, and the world at large will benefit by more agricultural yield. Okay, so we're getting to really the real topic that of this evening, and to set the stage, we are talking about innovation in smart unmanned aerial vehicles and unmanned ground vehicles. In simple words, the flying drones, the metallic birds, we call aerial robotics, or in many other names. These are some of the interesting facts before we get into the discussion. By 2030, world population is growing compared to today, obviously, and climate change is challenging us. And on top of which, today's newspaper highlights 60,000 tons of some food from one country to another, meant for another country, destroyed during the conflict between two countries. All of you know what I am talking about. And so international conflicts are ongoing, and food crisis is no longer a hypothesis, but real problem to solve by us. And India has, as per a research done by KhetiValah and published in its books, we have 179.9 million hectares of cultivable land. Are we really doing right with all this area of land, our fields, agriculture fields, or are we doing things right or not? Machines have come already all over, and including in agriculture from 1960s. But post industry 4.0, 5.0, 6.0, and 7.0 are being envisioned, where more automation and autonomous or self-driven vehicles on the ground and in the sky will be necessity than a technological breakthrough alone. This applies very much to agriculture also. We will justify during this dialogue. We have very golden opportunity being a participant to add value to the discussion. And I'm hearing that many attendees are already working on these areas, and I'm very happy to start the dialogue now. So in this today's dialogue, we have Dr. Gayatri M. Foddy. She is professor and head electronics and telecommunication engineering of Sandeep Institute of Technology Research Center, Nashik, and Dr. Sumita Mishra, professor of Amity University, Lucknow. And so we first begin introducing the first speaker. Dr. Gayatri is a professor and head of ENTC department of SITRC Nashik, and approved PhD guide of SPPU Pune, and mentor for Sandeep Technology Business Incubation Center, mentor for SIBIC TBI and Kolhapur, and IEEE senior member along with me. I am also a member of that, and student branch counselor, president Institute of Innovation Cell, and NISP coordinator, head for Women Empowerment Cell. She has immensely helped youth in various innovations. And in the field of agriculture, she authored a book chapter on precision agriculture along with Dr. Omkar and myself, which is published by Wiley and sold in Amazon and being translated to Chinese language. And to quickly talk about our next panelist of the day before I hand over to first panelist. Dr. Sumita Mishra has more than 19 years of experience in the field of academics and research. She works closely with Lucknow-based agriculture fields. Dr. Sumita has received doctorate in Dr. Ram Manohar Lohia Awadh University and MTech in optical communication from SGSITS Indore. She's affiliated with the Electronics Communication Department, MIT School of Engineering, Lucknow, UP. And she currently, her current research interests include deep learning, machine learning, applications in agriculture, visible light communication, and Internet of Things. These are crisp a few points about our learned colleagues, professors. And my ask for audience is ask your questions. If you wish, you can type the questions. We will let you to ask yourself, or we speak on your behalf and get the answers to you either instantly, now itself, or through follow-up mail. And each panelist would speak for 20 minutes, and 10 minutes would be equally divided for questions for either of the panelists, and we will conclude with audience participation. Thank you so much. And now I will stop my presentation, and I welcome Dr. Gayatri to take over from here.
Thank you, sir. So, for all, I must congratulate KhetiValah for such a great achievement and the great agenda they carry along with their startup. So, what I understood from your presentation, sir, so KhetiValah is working on complete ecosystem of the agriculture field and thinking of the economical growth of the farmers. So, congratulations, KhetiValah and entire team for this mission. So today's topic of discussion is UGV and UAV based approach to agriculture. I'm Dr. Gayatri Fade. I'm head of electronics and telecommunication department and mentor at Sandeep TVI. Let us continue to today's topic. Is my screen moving, sir?
Yes, ma'am. Continue.
Yeah. So as KhetiValah is nothing but the farming and agriculture. So nowadays a traditional farming is adopted the precision farming. So let us understand what is the precision farming. Precision farming is to increase the efficiency, productivity, sustainability in the agriculture production while minimizing the waste and negative environmental impact. This farming method employs a combination of technology, data, agronomic expertise to make more informed decision about the crop management. So if we see the components of this precision agriculture, global position system, that is the GPS. With this GPS technology, the farmer can accurately determine the geographical location of the equipment and crops. It enables precise mapping and monitoring of the field, which helps in making target decisions. Next is the GIS. GIS is a Geographic Information System. This GIS integrates with various data layers such as soil types, topography, and historical crop data with spatial information. This enables farmers to create detailed maps of their fields, helping them to understand variation within the landscapes. Next is the remote sensing. The remote sensing can be conducted with different kind of equipment, such as the drones or satellites. It provides a valuable data about the crop health, what is the growing pattern of the crop, what is the stress levels, and such information helps farmer to detect the early signs of the issues and take timely action. So one cannot control the climate, but with such technologies, a predictive action, a corrective action can be taken to reduce the damage. Next is the Internet of Things. IoT is a buzzword nowadays, and IoT in the precision farming, that is nothing but the sensor installed on the field or on the equipment collect the real-time data on the factors like soil moisture, temperature, humidity, and plant health. These are the key parameters which are required for growth of any crops. So based on the data analytics of this data collected with the sensors, one can predict the health of the crop. This data assists in making the informed decision regarding the irrigation, fertilization, and the pest management. Next is the VRT, that is the variable rate technology. VRT allows farmer to apply the inputs like water, fertilizer, and pesticides at variable rates based on the specific needs of different areas within a field. Traditionally, farmer used to spray the fertilizers or watering the crop as per his predetermined schedule or as per the guidelines given by their ancestors. But nowadays, based on this data, the utilization of the water, fertilizer, pesticides can be optimized, which reduces the wastage and ensures the optimal use of the resources. So unnecessary expenses carried on the fertilizers can be reduced with this VRD. Next is the automated or smart machinery. Precision farming often involves tractors, many sprayers, and many semi-automated automated machinery, such as the self-driving tractor, robotic harvester, which can increase the operational efficiency and reduce the labor requirement. These automated machineries are nothing but the UGVs. That is one of the topic we are going to discuss. What are the benefits of precision farming? It increases the crop yields by tailoring the inputs and treatments to specific areas of the field. Precision farming can optimize crop growth and maximize the yields. Whatever the resources that can be utilized efficiently. So resource efficiency is the one of the benefit. Precision farming optimizes the use of water, fertilizer, and pesticides. Right now we have discussed about it, reducing the waste. Next is the cost saving. Yeah, someone is anointing it.
Yeah, please, audience, let the panelists do the presentation. So don't do any writing. Thank you.
Yeah, next, right now we discuss is the smart machine. These smart machines are nothing but the unmanned ground vehicle. The name itself indicates what is the unmanned ground vehicle. Unmanned ground vehicle is nothing but the unmanned name itself indicates it is the driverless ground. It sticks to the ground, and vehicle, which is the moving object with help of the wheels. It is the unmanned ground vehicles. So traditionally tractors were used, but now these tractors are optimized, which can move in the fields of the farmer for the spraying purpose, for cutting the weeds. Many applications are there that can be performed using the UGV. So hope you understand what are the UGV. These are nothing the smart machine. Here you can see what kind of the wheels are there. So the concept of this UGV, if you see, it can be uh, realized as the defense application. Yes, prior to this, these UGVs were used for rover as a defense application only. But now it is used in the farming. Here you can see the foggers are there, which sprays the fogs to reduce the humidity and moves around the field, irrespective of the wetness of the soil and all. It can keep moving in the field. To the right hand side, here you can see a structure of a smart machine. It is a combination of all field, that is the mechanical, electronics, computers. So it is a multidisciplinary uh, domain actually. All kind of engineers are required for this precision agriculture or to develop the UGV. Mechanical engineer can design the machine, works on the motors, tires and all. Electronics engineer designs a sensor and controller unit, the interfacing of sensor and control unit, which collects this data that we have seen, which is the data required for the precision farming, is the temperature, humidity, soil moisture. Based on that, farmer can take the decision. Next role come is for the computer engineers. When this data is collected from the sensor, computer engineer do the analytics on the data and interprets it for the farmer for the action to be taken in the future. So what are the application of UGV for the soil and crop monitoring? precision seeding and planting. This UGV or rover is enabled with the arm. That arm is used to plant this or for the seeding or planting purpose. We can see it pictorially further. Autonomous weeding the crop, scouting and pest control. So weeding is the main problem that farmer has to face. This is weeding. Weed is nothing but the unwanted grass. That unwanted grass reduces the crop yield and its fertility. So removing this weed is a big challenge for the farmer. So it can be easily done with help of the UGV. So this UGV is used for the weeding the crop, scouting and pest control. Next, it is used for the harvesting. On YouTube, there are many videos which shows these robots or UGVs doing the harvesting. Automatically, it's collect or catches only the tomato. It doesn't harm to a single leaf of the tomato or fruit or anything that is going to harvest. So that is the smart harvesting technique that can be achieved with help of the UGV. Next is the soil and field analysis. Collect the soil, and based on the soil analysis, it gives the types. And nowadays, farming experts, based on this soil analytics, gives advice which crop can be uh, grown on the field. So such type of soil analysis is also important. And last is the remote sensing and mapping. We have already came to know about the importance of this remote sensing and mapping. Here you can see a UGV specifically designed for the precision farming. A robotic arm is installed on this rover, and you can see this is the solar panel, so that this particular rover can move in the field with the electricity generated with this particular solar panel, because on field electricity is main issue. AC cannot be reached to field at every point, so it operates on the DC. So this DC either can be generated from the solar panels or the batteries. But battery increases the weight of any vehicle, though it is a UGV or UAV. So this is the design of a particular UGV specifically developed for the farming purpose. Here you can see the pics. Robotic arm works on the rover side. In the picture B, the arm reaches the soil. It can move in the 360-degree mode. The arm grasps a sample at the maximum height, and with the rover, pitch angle is activated. So it is the pre-programmed or runtime adaptive programming can be done for the movement of the arm of this particular UGV. The last is compensate the slope and the step by using the pitch and roll angle to keep the landing platform horizontal. So here you can see at the top of this particular UGV, UAV is landed, that is the drone. So in farm, the land is uneven. So it may damage or it may not allow the smooth landing of the UGV. So such platform, this is the one of the application of UGV, the smart landing platform for the UAV. Also, it can give charging to the batteries of the UAV. So such type of UGV and UAV communication can be integrated. Next is the different types of the UGV specifically built for the different application. First one is just, it is not loaded one, it is the structure only. In second, it is meant for the cutting the grass, and third one is designed for the spraying purpose. So based on the specific application, this UGV can be designed. Next, come to the UAV. UAV is nothing but the drones. Now a drone is a buzzword. Everyone know about the drones, but UAV that is unmanned aerial vehicle, is nothing but the drones. That's why it's UAV. We understand the here, like UGV moves on the ground, UAV moves in the area. We understand. So here we are going to see UAV specifically designed for UGV have designed for the specific purpose. Likewise, UAVs are also designed for the specific purpose. For the precision agriculture or smart farming, these UAVs are designed. So some drones are specifically designed for aerial seeding and seedling surveillance. You might came to know through newspaper or anything how the aerial seeding is done on the particular area where hills and all. This aerial seeding is done, and this seedling surveillance is observed how they are growing and all. Second is the drones for the canopy and growth stage scouting. So when there is a huge canopy, this canopy need to be monitored and different growth stage to be monitored to avoid the runtime crisis happening nowadays due to the unpredictable climate changing. Drones for crop protection that spray chemicals to protect the plants and detect the illness of the pest. Next are the drones for the crop monitoring that collect the data regarding NDVI, leaf chlorophyll, and plant and status. These are the parameters specifically related to crop. Agriculture students can better interpret these terms. Next are the harvesting drones, which detects the crop maturity. They map the entire field over the 10,000 hectare per variation, seeding trends, seedling emergence, crop growth parameters, grain maturity, so on and so forth. Again, this is all possible with the help of the sensors, let us say a camera. The picture images captured in the camera. Data analytics will be done on those images, and interpretation is done to have the better interpretation gives the comments on this crop maturity. Next is the octocopter. There are the quadcopter having the 4 ECS, hexacopter, octocopter. Likewise, there are the variation in the uh, mechanical structure of the UAVs. So this octocopter having 8 wings are used to derive multispectral imagery of the crop and provide accurate digital data or imagery for the combined harvesters to operate. Next are the drones. Those are the vehicles that provide the periodic data about the soil terrain, boreal vegetation, and the moss growth. These are again technical terms related to the vegetation. Drone to study the natural vegetation, forest plantation, and the agriculture cropping beds. So these are the some application of the UGVs and UAVs, and these UAVs are specifically designed for this purpose. So here are the agriculture or precision farming applications of the UAV. These are the UAV in the precision farming. First application right now we have seen under the types of drones specifically designed for soil and crop monitoring. What is done over here, it monitors soil conditions and the crop health, provide real-time data on the soil moisture, nutrient levels, and temperature based on the data captured and the analysis done. Next is the precision seeding and planting. It autonomously plants the seeds with the precision, means that what should be the distance between the 2 points where seed to be sown, likewise, and consistency, ensuring optimal spacing and the depth for each plant. Next is the autonomous weeding. Right now we discuss the problem of the weeding. So UGV or UGV equipped with the vision system or UAV equipped with the vision system. Kindly read here UAV. Vision system and robotic arm can be identify the remote weeds. UGV deployed to scout the fields and identify signs of the pest or diseases for the early prediction, that is the crop scouting and the pest control. Next is the harvesting. Harvesting of the crops such as the fruits and vegetable. These robots can pick crops at the optimal ripeness, reducing the waste. These are the applications of the UGV actually. The heading is UGV in precision farming instead of the UAV. Kindly consider this. These are the UAV in precision farming, that is unmanned aerial vehicle. Here you can see nowadays this UAVs or drones are used in the spraying specifically. A specific application in precision farming is spraying, which is a proven nowadays, and farmers they have adopted this UAV for the spraying purposes. Here you can see why. Operating speed of this UAV is 3 to 6 meters per second. Flight endurance is the 1 hour, so it can spray up to 1 hour. Number of nozzles are 4. The 4 nozzles sprays at a time. It covers the 10-acre within the 1 hour. And here are the waypoints. Waypoints are nothing but we need to give the path to the drone or UAV where it can spray. Here you can see the path. This dotted line shows that path is already executed, and this dark line shows the path that UAV need to follow. So this is the application of UAV for the spraying purpose. So UAV or drone, everyone knows. 2 points to be considered while designing the UAV for the precision farming is the size of the tank, and second is the battery. So this is the payload that need to be considered while designing the UAV for precision farming. Here are some basic requirements for spraying that need to be considered. The drone need to fly in line with the predetermined waypoints. Right now we have seen what are the waypoints. It is the predetermined path given to UAV for the spraying that need to follow that path. Manage its flying height. It should be less than 3 meters from the crop. It sense and avoid the object while in flight. Objects like birds or any object moving around the field, it should be sense and avoid it. Otherwise, collision will take place and this UAV will collapse. So, sense and avoid the objects while in flight. Speed of the drone should be less than 6 meters per second. Land autonomously in accordance with the battery's condition. It need to check the battery condition and give the alert, and based on the battery condition it should land smoothly before the battery completely get drained. Use of gimbal to stabilize the captured images. So when images are captured for surveillance purpose or for crop monitoring purpose, this particular camera should be stable so that a perfect image can be captured. So that gimbals are advised to use for this purpose. A droplet size should be greater than 100 micrometer when spraying is done. So these all parameters are given by BIS, Bureau of Indian Standard for the Drone Rules. Kishore sir and me are there on that committee, and we have the points are same recommended over there. Considering weather condition, the drone-based spray should be permitted under certain conditions that is given. Wind speed should be 7 km per hour. Outside air temperature should be 35 degrees Celsius. Relative humidity should be greater than 50%. So this climate parameter should be monitored for flying the drones for a specific spraying purpose. And again, the weather condition, the fog should not be there. After immediate rain, it should not be flight. So certain climatic condition also we need to follow for the spraying purposes. Further, you can see this is we have seen the hardware, that is the body that is going to spray, but the soul, the software of the particular drone that is making that drone to fly in particular direction is controlled by means of the software. Here is the Indian software designed by the PDRL software company. Here it is the dashboard where you can give the points of your field or land in the particular software we need to enter. Then here you can map the waypoint. So here is the waypoint plotting. We have understood what is the waypoint. It is the path given to UAV or drone to fly for spraying or for surveillance purpose. One more additional benefit is that in between, we may have a particular obstacles in between which need to avoid while spraying. Likewise, unused area will be there, well will be there where spraying should not be done. So while mapping this waypoint, we can avoid this unwanted area where spraying should not done by means of this software. So here is the example of waypoint plotting. Space can be adjusted as per the land. Your land is visible here in front of you. In front of you on the screen, you can adjust the spaces where it need to be sprayed. Obstacle boundary implementation. Right now we discuss about the obstacle boundary. The obstacle may be rectangular or circular. Two options are given. So you can give the boundary in the polygon shape or in circular shape based on the obstacle. Everything is in front of you on the screen. Your field is visible on your screen. You can see the obstacles. You can mark the obstacles, whether they are in the polygon shape or circular shape. And when you give these obstacles, UAV or drone will not follow the path on the specified obstacle map on this waypoint plotted over here. So this is the beauty of this software. Next, Flyview dashboard is there. Here you can see this dark green lines shows that the UAV or drone has followed the path till, and it is rest of the area or waypoints where it is going to spray. In between, if you want, you can stop the spraying. So this is the one of the feature available with this. You can have the pre-check, that is the automated flight pre-check facility is there, where you can check the status of the battery, what is the current mode, GPS locations, starting points, motor testing, everything. Hardware also can be tested with help of this software. So you can test that whether a drone is ready to fly, whether the health condition of the drone is perfect to fly and all. So these are the parameter option. What should be the speed? What should be the spray rate? What should be the altitude? And fuel in the tank also can be monitored using this software. So when we ensure all these points, we can start the flight with help of the software. So two types of flying are there, autonomous or with help of the ground controller. So in autonomous mode, you can start sitting at your home. You can start the spraying of the drone, spraying with help of the drones, with help of this particular software. Resume option to continue from whether the flight stopped. So right now we have discussed that in between, if you want something is going wrong or something is the condition that you need to stop the spraying, you can stop. And after that, if you want to resume, it will resume from the point where you have stopped. So that is called as the resume option. So it will resume from that point where you have stopped the spray. So that is the option. And here you can see the flying methods, whether automatically you want to fly or you want to fly it manually. With automatic, you can spray by sitting at home. Next parameter is the adjust spraying flow rate according to the crop. So based on the crop or crop type, what is the requirement, spray flow can be adjusted. As we have seen here, we can also monitor the fuel in the tank, as well as we can also control the spraying flow. So that is all the beauty of this particular software. So key features of this software are equal and uniform spraying can be done, calculate and control the dosage of the liquid with the help of the flow control, avoid spraying in the neighboring field. That is the main issue, because when we spray, it may affect the crop of neighboring field. So with help of this software, with mapping the obstacle properly, a spraying in the neighboring field can be avoided. Precise tracking and resuming non-completed flights with the resume option that we have discussed. Plot spraying mission on the field and perform mission planning on cloud. So this is the advantage. Now you might be knowing about the cloud technology. So from anywhere you can monitor and plot the spraying mission. To be on the field for this map. These reports are required for generated and can be used for the further use. Obstacle avoidance to perform the efficient spraying. We have seen that feature also, and optimization of the resource. With this, the battery optimization is there. With this, fertilizer optimization is there, and manpower utilization is there. So resources are used optimally, and with this, it is helpful to improve the yield. Next use case for this UAV. First use case we have seen for the spraying. Second use case is that in Rajasthan, Gujarat border, in 2020, lot of locusts came from the Pakistan, and here you can see the picture, what was the scenario at that time. It was not possible to control it by human being. So in that scenario, then with help of the UAV or drone spraying, the particular liquid is sprayed, and you can see the effect over here. All are there are died, and this is reduced in this way. Here you can see the weed particular UAV used for the weed control. By spraying the chemicals on the particular part of the weeds, those weeds are made ineffective. So these are the different use cases of the UAV for the precision farming or the agriculture. Next resource for this is the water. In Chennai, there are a lot of larvae in the water. So again, chemical spraying is done with help of the drone. Here you can see, and there was the control or the problem. So this is the another use case for the water management. Next is the crop health monitoring. Crop health monitoring is done by the camera installed on the particular drone or UAV. Here you can see the design that is different from the drone that is designed for the spraying. So that's why initially I told that the design of the drone changes as per the application. So by capturing the image, these images are sent on the cloud, and from cloud, the analytics is done. Mishra madam is going to highlight on this how to capture and what data analytics to be done on this captured image will be discussed in the next panel discussion by the madam. Now, next part comes the communication. This is the science now, how they interact, how the networks is there. So for the communication of this UGV and UAV, so this is the smart means obviously computer is there. Obviously,
yeah, ma'am, may I request slightly faster because we announced around 1 hour. But no problem. You conclude, ma'am. The total, I mean, you don't skip anything. Just a suggestion. Okay. Thank you.
Okay, sir. I will fast forward it. The main part is discussed. This is the technicals behind the screen. So how the communication. So main ad hoc networks are used. I'm not going to explain what is the ad hoc and all. You can see the picture and can interpret now why the ad hoc networks are there, because it is the communication that is required from the ground vehicle or for the movement of the, as we are saying, it is the unmanned. For moving this particular vehicle, guidance is needed, which is given by this internet. So two types of main network is the mobile ad hoc network used for this movement. So it is used for UAV to UAV communication, UGV to UGV communication, vehicle to vehicle communication, ship to ship communication. But there is not a network which communicates between UAV and UGV. So these are the classification of the MANET. We are going to focus on the RANET and FANET. FANET is used for the UAV communication and RANET is used for the ground UGV communication. So here I have given the details about the FANET. What are the challenges are faced by FANET? Applications of FANET. Next is the RANET, which is used for the UGV communication. These are the characteristics and applications. The comparative studies of this FANET and RANET. What is the node type? You can see FANET is used for the drone and RANET is used for the UGV. What is the node speed, mobility, topology, coverage? So this is the comparative study, FANET and RANET, because you have an interaction between UGV and UAV. This FANET and RANET should be combined to design a new communication network. So this is the opportunity for that, which is UAV to UGV, UAV and UGV integration. We have seen the benefits of UGV, we have seen the benefits of UAV. If both are integrated, that will be the next level can be achieved in the precision farming. So here, this is the hypothetical view of UAV to UGV communication. Conclusion. Thank you. Thanks for the opportunity. I'll stop sharing. Thank you, sir.
Thank you very much, ma'am, for that excellent detailed discussion on your research work, and also it focuses on a lot of work that academic and industry need to pursue further. So without much delay, we'll take question and answers after second speaker. And all of you kindly write down, and then our team will collate and pass on to the for onsets. So may I now request Dr. Sumita Mishra to present her views of the same subject matter.
So, first, I would like to congratulate measures for initiating this KV Dialogue, and I hope that it will help connect the farmers with the current technological interventions. Let me share it in the Okay. So, first, as Adam has already explained UAVs and UGVs in detail, so I won't be much on these. I'll just briefly mention that UAVs and UGVs are basically some agricultural vehicles which are used to smart farming solutions. UGV is basically ground based. and UAV is unmanned aerial vehicle. So as you saw previously, UAV and UGVs are used for many applications. And what is the purpose of using UAVs and UGVs? Because we want to gather a huge amount of data in areas which are very, very large, and we use UAVs and UGVs. I would request somebody.
Yeah, except presenter, kindly everyone stay muted. Thank you very much for cooperation.
So as I said that UAVs and UGVs are basically having a lot of sensors installed in them. Okay, so what are the purpose of these sensors? These sensors are basically gathering data in real time, and this data can be used to improve the decision making in farming. Like if you do a survey with UAV or UGV and you find that there is uh, pest infestation in some part, you can use spraying. Or if you see that irrigation is not properly done in some part, you can take remedial measure. Okay, so that is the main purpose of introducing UAVs and UGVs in agriculture. So I have basically seen two trends in UGVs. Mostly people either use conventional agricultural vehicles like tractors and modify them for automation, or what they do, they develop specific solutions for a particular problem. Like what they do, if you have the problem of harvesting, then you will develop specific mobile platforms for harvesting only. Okay, so this is the two ways in which it is done. So drone, madam has discussed in detail, so I'll be touching upon only a few things here. So UAVs are equipped with many sensors, but perhaps the most important sensor there is camera. So in any kind of camera system, there are two parts. One is capturing the pictures, and the second part is software or processor, which is basically extracting the meaningful information from captured video or images. This is very important because once you get those pictures, you need to find out whether that information that you want is retrieved properly or not. So that is one of the things. Processor is very important apart from the camera. So you see that drones are generally equipped with visual cameras, and most of us are familiar with visual cameras, which are basically RGB cameras, capturing red, blue, and green bands. And then the second category is most commonly used one is thermal camera. Thermal cameras work in infrared range. Basically, thermal infrared range is in 8 to 14 micrometer region, because this is more suitable for conditions when daylight is not affecting your reception. Then the next category is multispectral camera. Multispectral cameras are the cameras which take images in many spectral bands. So when we talk about multispectral, typically 10 bands are used, but you can have at the most 15 bands in multispectral cameras. So they capture the information in different bands, and some bands are suitable for one kind of problem. Other bands are suitable for other kind of problems. So if you capture it in different bands, then you can extract more information from the collected data. Last one is hyperspectral camera. Hyperspectral camera is basically a very complex equipment because it detects images in hundreds of what should I say, bands, and these bands are very narrow, 10 to 20 nanometer differences there between two bands. So, how do this helps us? Basically, any kind of farming issue which you see, like weed infestation or diseases in plants or nutrient deficiency, any kind of such issues will change the physiology of the plant. So, what will happen? Crop will be affected due to these issues. Then its reflective properties will change. So in simple terms, you can say that healthy crop and a crop which is affected by some issues will be having a different kind of uh, different kind of sunlight reflection. Okay, so that is the important thing here. And next, once we have taken the images, we need to process these images and videos. So we use a lot of algorithms for getting the information correctly. Some of them are machine learning based algorithms. So I'll be deliberating on that later part. The later part. Just let me show you some major applications of UAVs in agriculture. Since Madam has already explained this thing in very much detail, so I'll just in a line explain about all these problems. Irrigation monitoring is basically possible through images captured from UAVs because, as I said, that different kind of soil and different kind of crop will have different spectral signatures. So from the captured images, we can find out that if there is any requirement of irrigation in a particular area. We can also gather this information from the canopy of plants, and then we can take the measures accordingly. Then crop health monitoring, as I said, that disease plant and the plant which is healthy will have different kind of signatures, so it is easy to get that. Similarly, field soil analysis, spraying, these things are discussed in detail earlier, so I'll skip this part. Recently, they have started planting using drones, and then what they do, they shoot pods, seeds, and all the crucial nutrients into the soil using drones. So that kind of application is also there. I have included one or two use cases here. This UGV developed by Japan's National Agriculture and Food Research Organization, NARO. Basically, you can see here it is a two-armed robot. Here you see this is a two-armed robot. Okay, and this can be used to detect apples and pears in this manner. It is basically a modified golf cart, and its camera can shown here. Its camera can capture a piece of fruit using these arms, and these UGVs will pick the fruits, and then it will put them in the basket which is there, and once the container is full, it can automatically change it to the empty one and keep collecting the apples or pears. So they have included in this a cutting edge technology using deep learning. They can identify fruit whether it is ripe or not by looking at the dent in the bottom of Japanese pears. So how they did this? They spread some 1500 pictures of apples and pears in Japanese setting, and using those kind of images to train the model, they were able to devise this kind of structure. Let me show you another example. This is a strawberry harvesting UGV. This kind of UGV was used to harvest these strawberry, and it can also determine the firmness of fruit and vegetables by using thermal imaging. Thermal imaging is basically, as I said, that thermal images can capture whether a fruit is ripe or not by monitoring the temperature of the fruit, and it is observed that there is difference of 0.2 to 1 degrees of temperature between the ripe and unripe fruit. Similarly, bruising is also detectable using these kind of UGVs, so they can categorize the fruits collected. So bruised fruit is generally not preferred, and they are rejected. So automatic sorting will help us with this problem. So I have included a very brief video here. Let me show you. Okay, so that was how the thermal imaging can help in inspecting various vineyards. It was shown there. So I have briefly written that what kind of drones are used here. So I'll be skipping this part and then what all we discussed in this discussion is that there are various solutions present. There are various things that can be done using UAVs and UGVs. But one thing is there, we need to look at specific problems that we are facing in our country. 41% of our farmers are small farms. So it is important to devise solutions which are catering to those kind of people. So we need to work towards developing solutions which are accessible and which are less costly. And with this, I'll be starting with some of our works that we are doing here. So as I explained earlier, that UAVs and UGVs use deep learning algorithms for getting the pictures sorting. So we have worked somewhat in this domain. Deep learning is basically a specific subfield of machine learning where what we do, we can extract images from the extract data from the image directly without using any kind of feature extraction. So I'll be discussing briefly what we have done. We have developed this model using Intel's neural compute stick. You can see here. So this is an edge computing based solution. Edge computing means that this device can be used along with drone mounted cameras. Basically, edge computing means that once we develop these deep learning solution and customize it for use on resource constrained devices, they can be used in real time. So that is a big advantage of this. So this is one work, and what we did in there, we used a GPU based system to create our model, and then what we did, we used that model to create a lighter model, and this lighter model was able to run on Raspberry Pi. Raspberry Pi is nothing but a small computer. So we used that, and with that we got an accuracy of 88%. So this kind of system can be directly interfaced with a smartphone or any camera which is mounted on UGV or UAV. Then, as I said, that lightweight models are very important to use for our Indian scenario. So this is another lightweight model which is based on MobileNet. MobileNet is also a particular system that can be used on resource constrained devices. Since okay, this is also one of the ongoing works of our. You see here that we have developed a model which can detect whether in a particular field you have a plant sapling, which is the crop sapling, or you have weed. So in this image, you see that there are bounding boxes around this image. So what it is doing, this YOLO-based model is basically detecting corn plant here within this particular section, and it is detecting another corn plant here, and it is identifying weed over here, weed over here, weed over here. So these kind of models, if you integrate it with UGVs, they can in fact pluck these weeds, and it can be helpful for farmers for automatically weeding out this. Then we also did some thermal imaging based disease identification. What we did here, we used two set of images. One was normal visual images that we took, and another set of images were taken from this fleet camera shown here. This is a camera which can be directly interfaced with various processors as well as smartphones, Raspberry Pi. So using this, what we did, we found that thermal imaging is somewhat better in capturing the details of disease, but the drawback was that it is a bit time consuming to get the image processed using this camera. Another of our works is basically we are working on, this is an ongoing work of a PhD scholar. She is working on using machine learning techniques to predict the yield in a particular area. We have included these parameters, and we plan to include image-based data also in this. So that was all from my side. I prepared the presentation for 20 minutes approximately. So these are the works which I have done. If any of you would like to know more about any of these works which are in the agriculture domain, you are most welcome to contact me on this. Thank you so much, sir, for giving me this opportunity. Thank you.
Thank you very much for yet another wonderful talk with a lot of technical details. May I request Dr. Gayatri also come on the video camera on. This is the token of appreciation from our team for both the speakers. When we meet you in person, we will hand over the bouquet and a memento. And audience, just clap for both the wonderful speakers of the day. And right now, whoever wants to ask question directly, this is for you, ma'am, the both of you. And any questions that are really top of your mind, even though you might have typed, if you want to speak, all of you, please try to raise. Maybe we will have 2-3 questions, given that it's about 7:45 now. So, audience, any questions?
Hello.
Yeah, carry on.
Yeah, I am Santosh. I'm the director of HBL Drone Technology, Hubli. Right now, we are being farmer. We are giving service to farmer regarding fertilizer and pesticide. I just want to check any of the herbicide trials have been taken for efficacy in a selective herbicide for any of the crop.
I think what we will do is a couple of responses from me. We have heard you and it is recorded. We'll get back to you. So, in fact, we are very keen on your area where you operate. We recently conducted University of Agricultural Sciences, Dharwad, a major event where Vice Chancellor Patil sir was there and a lot of other dignitaries. ISRO ex-chief was there. And so we would like to get back to you with a proper answer than giving you a half-hearted instant reply, sir.
Thank you, sir.
Any other questions?
I only have another question. That just latest presentation, the processing data, capturing images and processing that softwares and programs they have developed. So, are there now commercially available for the usage of now?
Yes, sir. Actually, we are in the process of patenting one technology. Then it will be available for commercial purposes. We will be doing a technology transfer for that.
Okay. Thank you.
So let me just take this opportunity to summarize. Dr. Gayatri started off explaining the concepts of UAV, UGV with ground data, and also given us the software that controls the hardware. And some of that indigenous Indian software development is taking place in Nashik. She's also leader of a technology business incubation. Some other episode will have her details on that. And Dr. Sumita pointed out some of the gray areas where India and perhaps the world needs to work together to come together and solve these fundamental challenges than working in isolation or silos. So it's a very good discussion, and it's also learning value to me as a learned, trained pilot certified by DGCA on agri drones and also contributing to BIS. It's really a very interesting discussion that we have had. And if there are no more further questions, may we conclude today? If there are any questions, we will give time for maybe a couple of minutes. So I individually would like to look at attendees. Some of them said they are working on developing UGVs and UAVs. I'd like to unmute and ask them to talk. I see Anand Purohit. Can you unmute, please? Yes, Anand, go ahead. Thanks for joining. You can also unmute your camera.
Hello.
Yeah, we hear you. You can unmute your camera.
Am I audible?
Yes, Anand. Yeah.
Yes, sir. So, good evening, all. We are starting to developing UAV and UGV tethered platforms for the agriculture purpose, and particularly in firefighting drones also. So, we are also looking forward to, do some JV in case of any kind of software development team, particularly in tethered UAV and UGV teaming platforms.
Right. And one thing that goes unstated is the logos on my body. So all these things are good and very nice to hear, but we need to build competences. So we need now a lot of pilots. We need drone pilot ecosystem also. So agriculture industry has to shoulder the shared responsibility to take this forward. We need around 6.5 lakh villages we have, and hardly some 20,000 pilots, out of whom 5,000 are certified by Directorate General of Civil Aviation, in spite of having 57 drone pilot academies. And so there is a need of the hour is all the agriculturalists and everyone else interested in taking this industry forward to work in taking all the, as Dr. Sumita Mishra mentioned also, don't work in isolation but solve the problem by working together in an integrated approach. So, with this as a takeaway, I would like to thank once again both the learned scholars, Dr. Gayatri M. Fade of Nashik, Sandeep Institute of Technology, and Dr. Sumita Mishra of Amity, Lucknow, and all of you, and for having attended. Anand Purohit, thank you very much for letting us know that you are very much in sync with the topic of the day. That is one of our missions, to connect with people. We will connect with you once again, and we will meet you in Gujarat. We are having a major event with the governor and others we will announce. and we will come and touch base with almost all the states in India. Thank you very much. Dhanyavad.